Question, we're asked to calculate the following for the given frequency distribution and round the two decimal places. We have the data ranges on the left and the frequencies on the right. We're asked to find the population mean and the standard deviation. The first thing we're going to do is find the midpoint. We're going to put that into the calculator as list 1. Then we're going to put the frequency in as list 2. And then we'll calculate the mean, the population mean, and the population standard deviation. So just keep in mind that the midpoint formula, we take the lower limit plus the upper class limit and we divide by 2. So for our first class, we're going to calculate the midpoint. I'm simply going to add the lower class limit, which is 50, plus the upper class limit, which is 61, and I'm going to divide by 2. And we get 55.5. I'm going to try to line this up. So the midpoint for the first class is 55.5. I can find the midpoint for the next class. I'm going to add the lower class limit, the upper class limit, and I'm going to divide by 2. And I get 67.5. So notice we can repeatedly find the midpoint, or we could actually find the first midpoint and simply just add the class width. For this example, in order to find the class width, I'm going to subtract consecutive lower class limits. So 62 minus 50 would give us a class width of 12. So I can simply take my first midpoint, 55.5, and I can repeatedly add 12. That gives me 67.5. For the next midpoint, I'm going to add 12 again. This gives us 79.5. I'm going to add the class width one more, 91.5. Our next midpoint is 103.5. And our last midpoint should be 115.5. So we're going to take the midpoint, we're going to put it in as list 1. We're going to put in our frequency as list 2, and then we're going to calculate the population mean and standard deviation. So in the calculator, I want to enter in the data. So I'm going to go into stat. I'm going to click edit, which is that first option. Remember to quickly clear a list. I can go to the very top of the list. I can hit clear and enter. I'm going to put in the data. Next, I'm going to put in the frequencies. All right, and I'm just going to check really quick. It looks like I have everything in correctly. Now, in order to calculate our parameters, I'm going to go back to the home screen. I'm just going to clear that out some. I'm going to go back into stat. I'm going to scroll over to calculate. I want to calculate the one variable statistic, so I'm going to hit enter. Since I'm working with two lists, list one and list two, I have to tell the calculator to do so. So I'm going to recall list one. I'm going to hit second and one, comma. I'm going to recall list two by hitting the second button and the number two. And now I'm going to hit enter. Now notice in the printout we see X bar. X bar is both the population mean and the sample mean. So for this example, our population mean would be 77.47, rounded to 2 decimal places. And for our population standard deviation, keep in mind that S of X is the sample standard deviation, and sigma sub X is the population standard deviation. So our population standard deviation here should be 17.04. Okay, so here we have the empirical rule as it's laid out. And notice we have X bar in the middle, and we have one standard deviation above, two standard deviations above, three standard deviations above the mean. And then notice we have the mean, one standard deviation below the mean, two standard deviations below the mean, and three standard deviations below the mean. So the empirical rule says that 68% of the data lie between one standard deviation, 95% of the data lie between two standard deviations, and 99.7 lie between three standard deviations. Notice in the problem that we are given the mean, and we're given that the mean is 62. And notice our empirical rule is centered at the mean. We're also given that the standard deviation is 8. So I'm going to fill in the rest of the chart. So if I go one standard deviation above the mean, I'm simply going to add 8 to my mean. So notice here we have one standard deviation above the mean is X bar plus the standard deviation. So I'm simply going to add 62 plus 8. That should give us 70. I'm going to add 8 more. That gives us 78. I'm going to add 8 more, and that gives us 86. I'm also going to subtract the standard deviation. So notice here we have X bar, which is 62 minus the standard deviation of 8. So 62 minus 8, we have 54. I'm going to subtract off 8 again. So 54 minus 8 is 46. I'm going to subtract off 8 again. So we have 38. So now we can answer the following questions. So it says 99.7% of the widget's weight lie between what two values? So if we look at our empirical rule, we can see that those two values are 38 and 86. So that's 38 and 86. The next question asks what percentage of widget weights lie between 62 and 78. So here we have 62 and here we have 78. So I'm simply going to add the 34% plus the 13.5%. So notice we're given the actual probabilities or areas. So if I add 34 plus 13.5, that gives us 47.5%. So 47.5% of the data lie between 62 and 78. And lastly, what percentage of widget weights lie between 54 and 70? So from our chart between 64 and 54 and 70, we have 68% of the data. So when you're answering this question, I would advise that you have this empirical rule handy. Our next question asks for, or it's in terms of pulse rates in beats per minute, and they were collected from a random sample of females who are non-smokers but do drink alcohol. The pulse rates before they exercise had a mean of 75.09 and a standard deviation of 10.3. The pulse rates after they ran in place for more than 1 minute had a mean of 125.68 and a standard deviation of 25.75. The pulse rates before they exercise, were they A, more consistent, or B, less consistent than the pulse rates after they ran in place for 1 minute? In order to answer this question, I want to draw out both of our curves on one number line. So here's what I mean by that. For our first mean for the non-smokers before they exercise, the mean was 75.09. So I'm going to guesstimate that at about 75.09. And it said that they had a standard deviation of 10.3. So I'm going to take 75.09. I'm going to clear out my home screen. 75.09. And I'm going to add 3 times the standard deviation, which is 10.34. And I get a value of 385.43. So I'm not being really precise with this actually being drawn on the scale. I'm also going to take the mean 75.09 and I'm going to subtract I'm going to take 75.09 and I'm going to add 3 times the standard deviation, which is 10.34, and we have 106.11. So this is 106.11. I'm going to take the mean minus 3 times the standard deviation. So notice this is following the empirical rule. I get 44.07. And this is our curve. I'm going to look at the second curve. The mean is 125.68. So now if these things were consistent, 125.68 would be somewhere here. Again, this is not drawn to scale. For the second curve, I am going to take the mean, 125.68, and I'm going to add 3 times the standard deviation, which is 25.75. And that gives me 202.93. So I'm going to guesstimate 202.93 here. I'm going to subtract 3 times the standard deviation, and that gives us 48.43, which is about here, 48.43. Which looks like this. And it says the pulse rates before they exercise. So look at the pulse rates before their exercise. Notice the range on this. So notice that the pulse rates are more consistent, which means that they're not as spread out as the pulse rates after they ran. So the solution here would be more consistent. You basically want to look at the spread, since the spread of the data in the first normal curve is tighter than the second curve. So notice this first curve goes from like 44.09 to 106.11. The second curve goes from 48.43 to 202.3. So the data is more spread out. The pulse rates are more spread out after their exercise compared to before they exercise. The pulse rates were not as spread out. Okay, so the answer here would be more consistent. Okay, for our next example, it says a normal distribution has a mean of 101 and a standard deviation of 10. We're asked to find the z-score for the data value of 96. So here's the formula to find the z-score. It's equal to x, and x is just the given value minus the mean divided by the standard deviation. So in this example, we're going to treat x as 96, right? That's our given data value. The mean is given as 101, and the standard deviation is 10. So I'm going to put all these things together in that z-score formula. So we have 96 minus 101 divided by 10. So you want to keep your signs as well. 96 minus 101. That's going to give us a negative value of 5. And negative 5 over 10 is negative 0.5. So a data value of 96 has a z-score of, in this case, has a z-score of negative 0.5. Next, we're asked about correlation, and we're asked to match each of the scatter plots shown with the best description of correlation. Now, as you read graphs, and this is any graph, scatter plots, any graph, We read them from left to right as we read sentences from left to right. So notice as we read this graph from left to right, it seems like the cluster of points could be summarized by a straight line, right? But as we read the line from left to right, notice that this line is descending or going down. The slope on this is negative. So A would have a negative correlation because all of these points are close to the line. For the next example, as I read this scatter plot from left to right, I don't see any up or down patterns. Therefore, this would have no correlation. And then lastly, as we read this graph from left to right, notice that there is an upward trend. And as you read this from left to right, it ascends or goes up. So therefore, this has a positive correlation. Now, in the next example, we are asked to match in the next example, we are asked to match the correlation with its value. See if I can put all these on one screen. Okay. So notice the first thing I'm going to look for are patterns. So you'll notice for B, notice that these points are tight about a line, and the closer to the line your points are, the closer to positive one or the closer to negative one your correlation may be. For B, since these points are tight about this line, and as we read this line from left to right, we know that the correlation has to be positive and close to 1. B is going to have a 0.99 correlation, right? Because a correlation, it runs from -1 to +1. So -1 being a strong negative correlation and +1 being a strong positive correlation. Now, if we take a look at C, notice that as we read the scatter plot C from left to right, notice that the graph descends. Notice that the points are tight about this line, which means that the correlation would be really close to -1. So the correlation for the last, or for plot C, excuse me, is -0.97. And if we look at A and B, so notice what's left on for our answer choices. We have 0.21 and 0.39. So taking a look at graph A, as we read graph A from left to right, notice that there tends to be some positive, not very strong, but notice that there could be a straight line that could be drawn through those points, but the correlation is not really strong. Since it's positive, the only positive number left in our answer choices is 0.21. So graph A has a weak positive correlation. And if we look at example B, as we read it from left to right, notice that there is a downward trend, somewhat downward. Notice that the points are not very close to the line, but it's still like a negative trend. And by the process of elimination, I believe the correlation here would be -0.39. All right, in the next example, we are given a data set that outlines the student scores on an algebra test. So we have the score ranges on the left, we have the frequencies on the right, and we actually draw a histogram. So notice on this histogram, we have on the horizontal axis, we have from 40 to 100 going by tens. And on the vertical axis, we have 1 through 7, which represents our frequency. So if we take a look at the first data range from 40 through 49, we have a frequency of 6. So I'm going to go from our first interval from 40 to 49, and we have a value of 6. From 50 to 59, there were a value or 3 counts. So I'm simply going to go up to 3. That's the frequency. For 60 through 69, we have 6. I'm going to draw my bar at 6. In that interval range from 70 through 79, there's 6 again. 80 to 89, there's 6. And 90 to 99, there's 6. In this example, number 20, research was conducted on the amount of oxygen runners could utilize during training, known as their VO2 max, and their finishing times are given in a race to see if there was a significant relationship between their oxygen level and their finishing time. We're asked to calculate the correlation coefficient, find the equation of the regression line, and also predict the time for a 5K runner whose oxygen level was 35.08. So what we're going to do is we're going to enter the oxygen level in as list 1. We're going to put in the finishing time as list 2. We're going to calculate the correlation coefficient, the regression line, and also predict the time for an oxygen level of 35.08. So the first thing I'm going to do is put the data into the calculator. So again, stat, edit. I'm going to clear out the 2 lists. And I'm going to put in the data. Okay, I'm going to check. All right, so now that I have the data into the calculator, I'm going to go back to the home screen. In order to find the correlation coefficient on your calculator, you must turn on your diagnostics. So in order to do that, I'm going to go into the catalog, which is above 0, and it's a second function. So I'm going to hit second and 0, which is catalog. I'm going to scroll down to the D section and I'm going to look for diagnostic on. And you only have to do this once. So now that the diagnostic is turned on, it will calculate the correlation coefficient. So in order to calculate that coefficient and find the regression equation, I'm going to go into stat. I'm going to scroll over to calculate. I'm going to go down to linear regression AX plus B. And if you remember from college algebra, slope-intercept form of a linear equation was y is equal to AX plus B. So here there's just substituting A for M or M for A. I'm going to hit enter. I must tell the calculator what is X and what is Y. So list 1 is X, comma, list 2 is Y. And if I hit enter, it gives us a few things. It gives us the coefficient of A, the coefficient of B. We're also given R squared, and then we're given our correlation coefficient of R. So notice we're asked to find the value of R, and that value of R is negative 0.973. We're asked to write out the regression equation rounded to 3 variables. So notice we're given that equation y is equal to ax plus b. So I'm going to simply substitute a as negative 0.59x. We're rounding to 2 decimal places, plus 46.93. So that is our regression equation. Y is equal to negative 0.59x plus 46.93. The last question, we're actually going to use that equation to figure out the finishing time. So just keep in mind that the oxygen level, those are the X values. That's what we put in the list 1 on the calculator. Once we put in a oxygen level, the equation is going to give us the Y variable, which is the finishing time. So here I actually want to find, I'm going to use that equation, y is equal to negative 0.59x plus 46.93. And I'm going to substitute x for 35.08. So I'm simply going to just put all of that in the calculator. So I have negative 0.59 times x, which is 35.08 plus 46.93. And we have a finishing time of 26.23. Thanks for watching.